I'm Everton de Oliveira, the Professor Água from the Groundwater Project, and I have the pleasure to bring to you the nice book, Properties of Organic Contaminants. I've been teaching this subject for so long, and I really miss this book. You should have done this book before, dear authors. It would have helped me so much, and I believe so many others in many universities. So I have here for you the authors. Doug Mackay is an adjunct professor emeritus, retired from the University of California, Davis in 2017. Richelle Allen-King, she's a professor at the University of Buffalo. And Bill Rixey, William Rixey, the full name, is an associate professor in the Department of Civil and Environmental Engineering at the University of Houston. Welcome, guys. And please tell us a little bit about yourselves and how you have teamed up to bring us this book, please.
Okay, well, I think the three of us had agreed that I would do the initial talking and then get out of the way. I started teaching these courses when I was at UCLA in 1986. I was teaching primarily to environmental scientists and civil engineers, and I realized if they wanted to learn about groundwater contamination, they probably should know a little bit about organic contaminants and their behavior and properties and so forth, and they knew nothing or almost nothing. So I started teaching then and gradually migrated my teaching to the University of Waterloo a number of years later, and of course was then teaching a different group, hydrogeologists and civil engineers. And once again, same problem, that in those disciplines, people simply didn't spend any time thinking about organic contaminants. There, I was lucky to pair with Richelle at some point in teaching this, and we produced a course that I think was really popular with detailed notes, which we were hoping we were going to publish at some point. It never happened. So Everton, this is finally our getting at least one portion of that work out. Then some years later, I realized, several topics that I was weak in, my colleague Bill Rixey was very strong in, and I had the luck of meeting him a number of times and crafting documents with him. So he just seemed like a perfect addition, and that's how we all got together.
Very good. Richelle?
I am a professor in the departments of geology and environment and sustainability here at Buffalo. Primarily, I'm in the geology department, and I've been working on organic contaminants as my main research area for my whole career, since Doug sent me off into facultydom. I'm very happy to have this book also come out finally, finally a portion of the book. There's actually more, but this portion is, I'm very happy to have it out. I agree with you, it'll be a great resource for teaching.
Very good. Bill?
Yes, as you introduced us earlier, I'm associate professor at University of Houston. Actually, prior to being at University of Houston, I was at Shell, Environmental Research and Development in Houston, prior to coming to the University of Houston. That's where I got my interest in remediation processes. That's when I was introduced to Richelle. She was a graduate student at University of Waterloo when I first started out. And also I became familiar with Doug because we had general interests in looking at fate and remediation processes related to MTBE and other materials that are present in gasoline and other petroleum products. Doug, so I've had several interactions with Doug since I came to the University of Houston related to some common projects. Particularly projects, Doug and I have been involved in several projects that have been sponsored by the American Petroleum Institute. So strong interests related to petroleum fuels and various components of petroleum fuels and how they behave in the environment. And so Doug and I have frequently interacted, and he added me to this team, to this book. Richelle and of course Doug did the major work with the book, but I've added some material related to various physical properties of organic components in non-aqueous phase liquids, and also related to how they transport the environment.
You know, if I could just jump in one more time, it's
Yes.
the other wonderful thing about both of these other two people is that they're fantastic editors. So they would catch things that I would miss, and maybe I caught some things they missed, I don't know. But having the three of us work on this was, for me, a godsend, because Bill, for example, before we began working on the book, caught me in some errors and calculations that I'd made on some physical properties of multi-component liquids. So I realized this is a guy that actually knows what he's talking about in this stuff.
It's
Pleasure
so
working with
easy.
him.
It's so easy to go into mistakes into this calculations. I know the feeling. I know exactly. One thing is that Doug mentioned, you know, when you're teaching to students, organic chemistry for hydrogeologists is kind of fuzzy subject for them to say, you know, to put it mildly. So let's say I'm not familiar with organic chemistry. How have you organized the information so I could profit from the main content of the book?
Right. Well, just a first comment, which is, it isn't really organic chemistry that this book covers. That's a pretty complex topic, and we touch on aspects of it. But the reason this is a useful book, I think, is that it introduces essentially anyone that's interested in groundwater contamination to some of the nomenclature, which is sometimes confusing, and also the important properties that anyone ought to know at least a little bit about if they're going to work on organic contamination of the subsurface. And I don't know, either of you other guys want to pipe up?
I think I agree with that on that one. I mean, that's it, right?
Thanks for sure.
Okay. Okay. So I'll go to a more generic question then. Why should we care about organic contaminants? And who is the target audience for your book then?
Right. Again, I guess I start the tirade here, but it's because they have shown up in so many different water supplies, and there are so many different kinds of them, and they all have different properties that affect their transport, their fate in the environment, and certainly their behavior and remediation. So that's one reason. The other reason is that although there are other kinds of contaminants, certainly like inorganic contaminants or microbial or viral contaminants, those are many fewer than there are organic contaminants, because organic compounds can, well, you know, you can create just about anything you can think of, and people have.
Bill, you're the more chemist than we are, I guess. So okay,
Absolutely.
Oh, just to add to that, I think, you know, the other thing is it's good to break down the classifications between inorganic and organic, you know, because there are common ways to look at the physical chemical properties of organics in particular. You know, Doug, Richelle, and I discussed that quite a bit in the book. I think you also give a nice introduction, Doug, with respect to structure of organic chemicals, give people an idea what the structure looks like, so then you can actually talk more about the properties. But I think it's useful to break the classifications inorganic and organic because of the common, you know, ways in which people describe the physical properties of organic versus inorganic, you know, materials.
Why else do we, why do our students want to look at this? Because organic chemicals, especially the ones that are a little more on the soluble side, they're used so much in society. Gasoline, dry cleaning solvent, degreasing solvent have been used for decades. And so they're in the ground where people want to use the water, and people need to know about them. So that's why my students want to know about them.
Yep. And another thing comes to mind, which is maybe a little basic, but it seems to me a very strong reason to at least become familiar with portions of our book is so that a person would know what the heck somebody else was talking about when they were giving a presentation or writing a book, or alternatively, wouldn't sound uninformed in such a discussion. So it's a way to build your vocabulary and become part of a much broader discussion.
I do agree with you. And one thing that when I first took your course, Doug, long ago, one thing the first impression that I had, and it still and lingers on forever with me, that impression is that when we think about organics, it's a huge world, lots of compounds and everything, and we say, well, how can I survive into this thing, right? And what the feeling that I had is that we learn properties, and we can work from properties with any compound, and it doesn't matter what it is, as long as you go for properties, you can understand, or you can anticipate what's going to happen into the field. This was so neat, and I really thank you for that course. That was so
Well,
nice.
you're welcome.
That's
And I'm glad you remembered it.
Yeah, absolutely.
So, and that's why I added the next question. So, like, for emerging contaminants, we're always talking about emerging contaminants for forever, right? So
Yes.
that's something, right, that will help, like how your book would anticipate or help someone anticipate the behavior of a given new compound in the subsurface. What is how is the book prepared for someone? I can give you one personal experience. When you go to an industry, and you go to these guys that been their whole lives working with a given number of compounds, and they talk about these compounds like it was bread and butter, and we don't know what the heck are those, right? And now we don't have to feel afraid of them, because we can use your tools. So please tell about the tools in the book that will help us understand.
Well, right. So again, guys, I'll just give it a start, but that's the whole point of the book, in a sense, is that there are properties of organic contaminants that, as Bill mentioned, are reasonably well known, and in some cases predictable based on structure. But even if you're only interested in a qualitative set of insights, you can get those too by looking to see whether the contaminant is non-polar, for example, and the book describes what that means, or whether it's polar, it has components that would tend to allow it to dissolve better in water, or that it has some other properties that make it partition from water into a vapor phase, and so on. So I think even a skim of our book would give people a pretty good overview of those things. So presented with a new compound that they never heard of, or that nobody had ever written anything about, they might be able to make a first good guess on whether it's soluble, whether it would be insoluble, whether it would transport quickly or not, and so on. So it gives you a leg up to start. Boy, what else can you do with a new chemical? You got to start somewhere.
Yeah, the other thing is that the chemicals that are new to us in the environment are not new. They've been used, they're around. And so actually, usually, and now with chemical property databases online, there's usually an engineering handbook that already has the properties. And even though we wouldn't list the contaminant properties in our book, you can look up the properties and then refer to the ones that are described in the book. And as Doug says, you find out if it's polar, apolar, and then we discuss that. Find out if it tends to be volatile or non-volatile, and you can compare that to the ones that are volatile. So you know what questions to ask, and then it gives you a framework to fit those in the environment compared to the other compounds that we talk about, that we know a lot about the behavior in groundwater.
Right. Looks like Bill's about to say something. Are you, Bill?
No, I was just going to say, I think you provided enough examples, in the book to, make those kind of assessments if you had a different or a new compound that you were dealing with.
Right. And we give one example that I'm familiar with because I encountered it long ago when I was at UCLA, and it was a chemical that a state laboratory had figured out was in groundwater, but they knew it was there, but they didn't know what it was. And they eventually figured that out by some pretty advanced organic analytical chemistry. And it had a simple enough structure and that it's you could understand why it was so mobile in groundwater and why it did some other things. And actually, we speculated that it would have certain other properties and proved that it did when we did some experiments with it. So that's an example of something that was not in any databases and yet thankfully was simple enough so that we could understand it.
It's true. It's true. So in the same way, how would it help, all the properties to prepare someone to design a remediation strategy for a given contaminant or mixture of contaminants, which is usually the case?
Boy, that's a good question. And I am totally willing to toss that one to Bill if he wants to tackle it, because I know he teaches a lot about remediation. I certainly have too, but Bill, you want to take a shot at that?
It's very, okay, I'll take a shot at it. I teach a course when I first went to UH, I put together a course in hazardous waste processes, focused on remediation processes. And, trying to develop a little bit of a semi-quantitative framework from which to think about how to remediate, soil and groundwater, how to think about transport. And so, one of the most important aspects in that is partitioning. If you can understand the equilibrium properties, that goes a long way in being able to think about at least a zeroth order approximation of what a remediation process might look like. Like for example, if you were looking at the partitioning from a organic phase to a gas phase, like benzene partitioning from gasoline to air, that partitioning process, which, one example of which is talked about in the, in the book, is very important for processes such as vapor extraction, soil vapor extraction as an example. So looking at the partitioning can give you a good estimate or idea of what remediation strategy might be a good remediation strategy. If you're looking at transferring from an organic phase to an air phase, or organic phase to a water phase, water flushing, for example, with water, or an enhanced flushing process. If you can understand the partitioning, that gives you a good first step in trying to understand how that remediation process, how effective that remediation process might be for a particular chemical. And you can apply that to mixtures as well. Again, it gets to how things partition from the mixture to the other phases.
And we also, just to expand upon what Bill said, we comment on how the presence of surfactants and co-solvents can strongly affect the behavior of a chemical under certain circumstances. And, people may know that both co-solvent flushing and surfactant flushing are known and applied remediation technologies. So the basics of the partitioning processes are described in our book.
True. Not only, I would expand that, because when we do chemical analysis, we do have to see if the results make sense. And with the background that we get from your book, it's all clear when the chemical results are not correct, and you can go to the lab and say, you made something wrong there because it doesn't make sense. And we can be pretty sure. I have lots of experience on that. So that adds to Bill's talk about the remediation. It's the same principles. We can interpret the results by knowing the properties. That's my feeling. What do you have to say?
I'd like to say just a comment about analytical results, because once you know something about the properties that we have covered, you can know something about what you will or will not see in a given analytical exercise. So, for example, some very common analytical methods applied to organics simply will not see an awful lot of the contaminants that might be present. Others might. And some of them depends on how the sample is prepared and things like that. And you can, if you think carefully about the analytical method that's being applied, you can perhaps recognize artifacts that may result. Otherwise, I'm not sure exactly what you're driving at, Everton. You're saying that if you notice that results might not make sense, give me an example.
An example, for example, when we think about when we have some mixture of contaminants, for example, which is usually the case, and you have a brief understanding of molar fraction of what should be in there, and then you have a high concentration that comes from nowhere, and so that's not possible, and that's clear when you understand the basics of what's in you show in the book. And it's not trivial for people that don't know that property. It's not trivial. So for me,
Yeah,
and there are others, but I just picked one example, but there are many other properties that tells us that something is wrong and we can pick. I know for you that is, you're working with that every day. So it's so natural that maybe you don't think about that. But I have a company and I see guys doing mistakes interpreting results that should have done it properly, and they don't see it. So with the book, I'm pretty sure they can see. That's my feeling.
it's interesting because one of the books that I hoped to get produced after this one would have discussed analytical methods, continuing on from the discussion of properties and so forth, then overview the kinds of analytical methods people would ordinarily encounter and discuss some of the very things that you're alluding to, I think. For example, if you see a very high concentration that's in excess of the noted solubility of the compound in water,
Exactly.
How could you have that? Well, if you had a co-solvent present, perhaps, or if you had a very strong surfactant, or it's possible. What about the reverse, where you expect to see certain concentrations of an organic contaminant in vapor phase based on their known properties, and you never see anything close to it? Well, maybe it's because it's in a multi-component organic liquid that depresses the partial pressure and so forth. And if you know enough about this stuff, you can start to hypothesize reasons for the issues you just described.
Exactly. That's it's when you it needs a lot of you have to do and go through the exercise on the book, because then you do see what we're talking about here. That's my feeling. And then when you see some chemical results, you can be sure that something doesn't sound too good or doesn't look, correct there.
Yep.
Right? That's very good. So
Yep.
I really appreciate the book, because we'll have a higher reach for people, when you leave North America and some other countries, we don't have organic contaminants courses in many universities, so it's going to be a huge success, I hope. Okay, so
we do too.
yeah, it will. I'll push this book a lot so people can use it. Don't worry. It is. I know how important it is. So guys, finally, the final question is, since most assessment and remediation projects are focused on organic contaminants, from my experience, maybe in mining we have something else, but usually we do a lot of remediation for organic contaminants. We don't know why is that, and why knowing the content of the book is be good for the environment. Just a final question to be, to put a good message for the reader.
Boy, that's a wide question. I think you've already set it up though, because, and so we all have. There are so many different kinds of contaminants, and they all have different properties, but some are similar, some aren't. And as long as we can begin to think clearly about the contaminations incidences that we encounter, we have a much better chance of monitoring and perhaps remediating them efficiently. Bill or Richelle, can you toss anything else here?
Let's just add to what we mentioned earlier, and that's the pervasiveness of organic, chemicals,
For Richelle, so yeah.
various locations, and also you look at the primary drinking water list. Most of the chemicals on the primary drinking water list are organic chemicals.
Yeah,
They're obviously inorganic and microbiological as well, of course, but it mirrors the the various forms that can be, different amounts of, there are different types of compounds that can be generated from organic based molecules. I think that's described in the book, Doug, where you come up with a reason for why organic compounds are so there's so many more organic compounds out there than organic compounds.
yep. Yeah, you look at the way they're built, sort of, and they look like a kit, right? A carbon and something attached to it, and you can
Lego, like Lego.
You can make virtually any dang thing you want, and
Yeah, that's true.
and thanks to chemical engineers, we have lots of those chemicals now. But
That's true.
and when they get out into the environment, we need to chase them down and figure out what to do about them. I will say one other thing, because I'm thinking about a project that Richelle and I were involved with, or I dragged her into. We don't always know everything about organic contamination at some sites, and maybe even most sites, because so many of the things that are present, which are known to be organic by way of very general analyses, are unidentified. So we don't know what they are. We don't know if they're a problem. We don't know if they affect the other chemicals that we do know about. And it's a very frustrating thing. Richelle and I looked at one site where it was one of the most contaminated places probably on Earth, and the chemicals simply did not behave like they would be expected to based on the compound properties. And the reason was unknown. I mean, it's something about this elixir of organic chemicals really profoundly affected this particular site. So there are these things that you could look for that are counterexamples, and those are equally as important as the ones that we understand more thoroughly.
That's very good. Very good. And so how did you manage that when you don't know what's going on?
Well, in that particular case, we were interested in how rapidly contaminants could be flushed out of a aquifer, and those basically everything was flushed out at the same rate, which was very odd and not at all expected. It was a site at which Shell actually had worked a bit, and there were multiple contaminants ranging from very mobile to very immobile contaminants, at least based on our expectations, and they all moved out at the same rate. So we knew something big time was happening, and yet none of our theories about co-solvency or surfactants or anything would explain that behavior. We ended up puzzled. Richelle did some laboratory experiments, confirmed a couple of things that suggested that somehow when you took that groundwater out of the environment and took it somewhere else, it changed. So we know a little bit more, but it's the questions like that I hope aren't too widely encountered, but there are the more complex cases where things are very mysterious.
Good. Well, that's the fun about research. If we knew everything, there wouldn't be a point to do research, right? That's interesting. Yeah. Good.
Yeah, exactly. Right.
So can I add a couple things to the, this doesn't have anything to do with the last question you asked, but
Okay.
a couple things that I really like about, Doug is clearly the leader on putting this together. And there are a couple things that I really like about the way Doug teaches and that show up in the book and that I've even modeled my teaching after. And one of them is that As a great teacher, he's a very good storyteller. And when I read the book, I can hear Doug telling the story of organic contaminants, just like he would in a lecture, which is very easy to read. And so
Very
I think
true.
it'll be easy for people to get through this, which is not normally what one thinks about when one thinks about organic contaminants or chemicals. And the other thing is that there are so many graphics that help you visualize these properties that we're talking about. And great care was taken even to try to represent many things quantitatively, schematic diagrams with the number of points that match the properties of the example compound and all this kind of thing. So I think the illustrations, everything from molecular models to partitioning models, et cetera, I think are designed to really make it accessible. And I know that all of us have found those kind of approaches helpful to our students. So I'm encouraged by that and hopeful that it's useful to people because of that. And these are a couple things I really like.
I do too. I do too. I'm with you on that. Bill.
I agree with that too. Richelle, especially the graphics. The graphics are really tremendous, or were a tremendous effort in putting that together. So I applaud. Those are largely due to Doug and Richelle. I applaud you for those graphics. In the textbook.
Mostly Doug. A little bit. I added a little, but mostly Doug.
Yeah. Well, guess why? I'm retired. And
Oh, okay.
I also like the it's presented in a very understandable presentation throughout the book, but there are sections there where we've tried not to lose rigor in the presentation. So I think that enables a reader that wants to make the next step to go to the more detailed literature that is in the references. They can understand that even better with the way Doug's and Richelle and I, presented the material.
Yeah, that's a really good point, Bill. And I guess one of the functions of this book is to create some interest, to make people not fear organic chemicals and to make them realize there's some pretty interesting things about them and that, they're welcome to go dig deeper. So we didn't want to scare people. We wanted to intrigue them. And I think this is a very digestible book.
Oh, for sure, it is. I read it, back to back. It's very digestible. It's very well put, the things there. I agree a bit with Bill, but Bill, I think it does what it's supposed to. The book. It's not supposed to be like an in-depth for a researcher that going for a specific point. But you can get a very good overview and you can understand and you can do a much better work in contaminant hydrogeology with just the basics that are in there. If you need more, of course, you can go. But I think it fits a huge, I don't know, necessity that we have for people that are working and believe that they're knowing what they're doing and they don't. Right, so it's going to be very welcome, this book. Okay, guys, I guess our time is up here. I'd like you to make your final considerations, please. Again, congratulations. I really enjoyed the book. I'm retired of teaching and I missed the book when I was teaching. That was too late for me now, but lots of other people would make a good use of this book. Please make your final comments and congratulations again for a job well done.
Well, sure. So here's here's the way I think about organic chemicals, and I hope other people might too. They're things. They are actual things. They're not just letters and little black lines on a piece of paper. They're little objects. They have a size, they have a shape, they have flexibility or not, and so on. And they are either very tiny or very large, but all of them, as far as I know, are larger than water molecules. So there's something very fascinating to me about thinking about these as actual objects.
I think I made my parting comments already before.
All right, thank you. Bill?
I'll just finish. I'm, glad to be part of this, this team, putting this, excellent little book together.
So Everton, keep bugging Doug for the next pieces of the book.
I will. I will. He just mentioned what's coming, and now I'm very anxious.
Sorry, Doug.
I'll
That's all
bug
right.
him. Don't worry, because that's so necessary, Doug. Please. All right.
Thank you very
guys.
much.
Bye. Good to see you all.
See ya.
Thank you, guys. Congratulations again. Bye.
Bye.